Hey guys, this is section 2 of graphing rational functions, finding holes. In the previous video, the topic was finding vertical asymptotes and how to state the domain of a rational function. So we're going to extend from there. And so last time you had steps 1 through 5. So you should already have steps 1 through 5 in your notes on the procedure on how to graph a rational function. Remember, we're still days away from actually graphing. We have a lot of stuff to build up to before we get that. So we talked about how the first thing we do is we factor the numerator and denominator. Then we cross out any common factors or reduce anything that we can. We want to write it in its lowest terms. Then whatever left over in the denominator, you're going to set it equal or not equal to 0, and then solve those inequalities. They're not inequalities, but they're I don't want to call them equations because they're unequations, I guess. I probably just made up that word. But anyways, you solve those to find the vertical asymptotes, which we've talked about, and that was also something that came from the rational expression inequalities, so we're familiar with those. And then how to state the domain. And domain is basically all the values of x except for the vertical asymptotes and any kind of factors that you happen to cross out. That's where holes come in. So after you state the domain, d of x, using interval notation, step 6, which we're adding to our list, and so hopefully you have this list in your notes already, 1 through 5, add number 6, which is find any holes. And that's what we're talking about today. So let's jump right to an example. So here's f of x equals x squared minus 9 over x squared plus 2x minus 15. Now, again, I don't want to say this every time, but my recommendation to you is to pause the video now, write down the problem, unpause, so this way you have it written down and you don't need to be writing while you're listening. You'll definitely miss some important piece of information if you're trying to write the problem down and listen to me at the same time. So I'm assuming at this point you have written down the problem and we're ready to go. So step 1, factor numerator and denominator. So the top is x plus 3 and x minus 3, a very common, very basic difference of two squares. The bottom's a trinomial, a basic trinomial, x plus 5 and x minus 3. And so at this point, you'll notice that we can cross out these x minus 3's, and that'll write our rational expression in lowest terms of x plus 3 over x plus 5. Now, setting that x plus 5 unequal to 0 and solving, we get our vertical asymptote that x cannot equal negative 5. And also from this, we get our domain, which is saying that we can be from negative infinity to, well, negative 5 is the next critical number. But then remember, we crossed out this x minus 3. That x minus 3, if we just write that on the side somewhere, x can't be that either. Even though we crossed it out here, x cannot be that. Now, it's not going to create an asymptote. It's not going to create a vertical asymptote. But x cannot be 3, because if x were 3, then this trinomial down here would end up being 0, and we'd be undefined. But it's not an asymptote because it got simplified. It got crossed out when we were writing the term in reduced form. So it does not get listed in the vertical asymptotes, but it is included in the domain as far as a limit to the domain. So x is all the numbers between negative infinity and negative 5 and positive 3, which is what we got from kind of solving this if it didn't cross out. Oh, sorry about that. And then x can also be all the numbers between 3 and positive infinity. So nothing really new here. This is what we did in the last video lecture, and this is what we practice in class. What we're adding is that this concept here of crossing out these terms, that this right here, it's an undefined number. X cannot be that value, but it's not a vertical asymptote because it got simplified. It got crossed out. So what is it? Well, here's your hole. It is your hole, but your hole, if you were to look at a graph, it would be graphed as an open circle, and when we get to graphs, that's kind of what you'll see. And so at this point, let's say this is 3, it wouldn't be a vertical asymptote. It would just be a hole on the graph, exactly what the word hole says. It'd be a hole. But we're not going to write down x cannot equal 3 as the hole. We actually want the coordinate of the hole. And so that adds a little bit of extra work to this. And so the way we're going to go about that is, I guess I'll leave that up there, is you get the coordinate of the hole by, first of all, we know that x cannot equal 3. That 3 is going to be the x value of our hole. Thing that crossed out here, and we solved it over here. So that x value of 3, that's going to be the x value of the hole. What we need to figure out is what would be the y value. And I've seen a couple ways to do this. I think there's, kind of a concept of limits, but we didn't really discuss limits, using your calculator. I think the easiest way to find the y value of the hole is to use our function here. The reduced form of our function is x plus 3 over x plus 5. So to find the y value of your hole, you're going to plug in 3 for x. That would be 3 plus 3 over 3 plus 5. That ends up being 6 over 8, which we can divide everything by 2 when we get 3 over 4. That's the y value of your hole. Oh, that looks like 9. 3 over 4. So we'll do a few more examples, but to kind of sum it up, factor the numerator denominator like we always do. And this, when holes exist, and if nothing crosses out, all you're going to write is no hole. And which is going to be the case in many times. But when a factor like this does cross out, that's going to be a hole. What doesn't cross out in your denominator, you solve for that, that becomes your vertical asymptote. The thing that does cross out, that's going to become your hole. Both of them, the vertical asymptote and the hole, combine to be critical numbers for your domain as far as limitations of what x can and cannot be. So let's look at another example. G of x equals x squared plus 6x plus 5 over x squared plus 3x minus 10. Step 1, factor. So this numerator factors to x plus 5 and x plus 1. The denominator factors to x plus 5 and x minus 2. And so we see that x plus 5 is a common factor, and that's going to cross out. So your hole is going to come from that. Your hole is going to come from, we have x plus 5 cannot equal 0. And so you solve it just like you do the asymptotes. X cannot equal negative 5. And so that's the x value of your hole, is negative 5. I want to write that with a clear negative symbol, negative 5. The way we're going to get the y value is by plugging it into the function that's left over after these crossed out. We still have an x plus 1. We still have an x minus 2. So if you plug negative 5 into those, you get negative 5 plus 1 over negative 5 minus 2. Negative 5 plus 1 is negative 4. Negative 5 minus 2 is negative 7. We can get rid of these negative signs and write it as 4 over 7. And so that is the y value of the hole, 4 over 7. And you can do the rest of the problem like you normally do. Our vertical asymptote we get by setting this not equal to 0. You end up with a vertical asymptote that x cannot equal 2. And that allows you to then state a domain. Remember, your domain includes the hole and the vertical asymptote. So we're going to go from negative infinity to, we have the whole x value is negative 5. That's definitely less than 2. So negative 5, or symbol, negative 5, comma, 2, parentheses, or 2, comma, infinity. All right, let's look at another example. This one's called f of x cubed minus 4x over 6x plus 12. And so we'll factor the numerator. Sorry, I'm having a little bit of a problem with the pen there. There we go. Alright, so let's factor the numerator. We could take out an x. We're left with x squared minus 4, and I think immediately you can see that that's a very common, very basic difference of two squares. Factors to x plus 2, x minus 2. And the bottom, you could take out a 6 and be left with x plus 2. And that's going to be the whole from that. So first of all, let me rewrite the expression in reduced form. F of x equals x parentheses x minus 2, sloppy, x minus 2 over 6. And so let's see, our vertical asymptote is, setting 6 not equal to 0. There's nothing to do down there. There's no x values left in the denominator, so your vertical asymptote is none. There is no vertical asymptote because there's no x's or anything down there. There's no variable down there for you to solve. So vertical asymptote is none. Sorry, everything having some trouble with my pen here. Hold on, just quick change in the setting, and hopefully that fixes it. So let's see, I need to kind of clean this up a little bit. Okay, vertical asymptote is none. Now, we did have a term cross out. That was the x plus 2. So when we know x cannot equal, what would make that 0? So x cannot equal negative 2. So we do have a hole. And it's going to be negative 2, comma, negative 2 plugged into our expression here. That would be negative 2 parentheses negative 2 minus 2, a lot of 2's up there, over 6. Negative 2 minus 2 is negative 4, so negative 2 times negative 4 over 6, you're going to end up with 8 over 6, which reduces down to 4 over 3. And notice a lot of times that is a fraction. That is going to be the case. And so the last thing we need that we're missing is our domain. So the domain of x is, let's see, we have a hole at negative 2 and no asymptote, so that's our only critical number to deal with. So we're going to have all the x values from negative infinity to negative 2, along with all the values from negative 2 to positive infinity. And there's your domain. All right, one more example, and then we'll wrap this lecture up. So here is the function g. My pen has fallen asleep once again. Here we go. We're back. And so factoring the top here. Now 2x squared plus 5x minus 3, that would require AC factoring, or using our calculator to trace out the roots. I'll do AC factoring real quick. AC is negative 6, and so I want to split this up into positive 6x and negative 1x. And bring down the front and the back, slice it in half. Take out 2x, left with x plus 3. Take out a negative 1, left with x plus 3. And then combine my GCFs of 2x minus 1 and x plus 3. So that's my numerator. Rewrite this over here. 2x minus 1 over x plus 3. And the bottom is a simple GCF. Take out an x, get x plus 3 left over. X plus 3 crosses out. That's the whole. So to solve for that hole, x plus 3 cannot equal 0. X cannot equal negative 3. To get the y value of that hole, it's going to be negative 3. Sorry, pen's dragging. New technology always takes a little getting used to. So negative 3, and then plugging negative 3 into our expression here, 2x minus 1 over x, that'd be 2 times negative 3 minus 1 over negative 3. The top would be negative 6 minus 1 is negative 7 over negative 3, and the negatives will cross out, so 7 over 3 is the whole. I do have a vertical asymptote. Simply x cannot equal 0, because setting this not equal to 0, there's nothing to do. You just get x cannot equal 0. And so the last bit is our domain, d of x. And our critical values are, we have a hole at negative 3 and an asymptote at 0, so negative infinity to negative 3, or negative 3 to 0, or 0 to positive infinity. And that's it, guys. That's the end of the lesson.